Hello. Yes, Shrikantji, I'm audible.
Yes, sir, you are audible. Very much clear.
Fine,
Yes.
fine. Let me connect the headphone also.
Yeah, please. So I think participants are also joining. Hello,
Okay.
everyone.
So you need to do some adjustment on my desktop, no?
Yes, sir.
One sec.
Hello. For all the
Yes.
participant, please note that you can use chat box or Q&A session for your reactions, or you can give the reactions also. Because for the better communication point of view, we have muted videos and the and your mic so that the communication and the will be more interactive. Whatever the queries you have, you can put up into the chat box or maybe Q&A session also. बैकग्राउंड सेट करना हो उनका Hello everyone. We'll wait for 2 o'clock as our schedule is for the 2 o'clock. So till time all the participant will join, and then at 2 o'clock we'll kickstart our webinar. Thank you. Hello everyone. Good afternoon.
Yes, good afternoon, Shrikant ji.
Good afternoon, Vijay sir. So I hope everyone is joining. It's 2 o'clock, so I think we should wait for another 2 minutes and then we'll start the discussion, sir.
No worries, no worries. Yeah.
So for all the participants, I just want to inform you that all participants are not will not able to switch on video and the mic. If you have any queries, you can put up your queries in chat box or maybe in Q&A section. So in that will reply you on your queries and we'll have a discussion on the QA part on during the Q&A session also. So I think we should start, Vijay sir, because the all participants are getting joining. Maybe in the due course when we start, the count will go on up because as we have scheduled time for 2 o'clock, so we should start because all participants is lined up accordingly. So first of
Okay.
all, let me thank you all participants for joining this webinar. And we'll make sure that you will get all the insights about the spray dryer plant for which this webinar is conducted actually. So give me a moment, let me share the screen and we'll initiate the discussion on our topic for the latest trend in the spray dryer design and energy improvement. Let me share my screen. So are you able to see my screen? You just give me a thumbs up or maybe any reaction in the chat box. Okay, thank you, Gautam ji. Okay, so I feel that my screen is visible to all of you, and Vijay sir, it is visible to you also.
Yeah, absolutely, absolutely.
Yeah, fine. So we'll go on discussing. So I have changed the screen. Now our webinar topic is innovation in spray drying technology with a focus on latest trend in spray dryer design and efficiency improvements. I hope you all are able to see my screen. Anytime if you feel that if you're not able to hear or not able to see screen, just put your comments in chat box or maybe in Q&A also. Not an issue. So this is our webinar topic which we will discuss today. So to get the more insights about the spray dryer technology, which directly gives us the direction and the knowledge about the latest trend in spray dryer design and efficiency improvements. And also we'll discuss the market potential about the spray dryer plant in Indian as well as global market context. So this is the our webinar content, what we will going to discuss in this particular webinar. I'm showing up the index of the our webinar points. So first is our webinar objective, which we will discuss, that what is the objective of our webinar for conducting such webinar, and what is our way forward in the discussion. Then the introduction of the experts, which we will elaborate on the experience point of view. And then overview of the spray drying technology, latest innovation and trends of spray dryer technology, efficiency improvements in spray drying, Q&A session, and bonus point and declaration for all the participants. So there are something with us which for all our participants we have designed this program, and that will be the some bonus points and declaration from our side, which we will pass on to our all the participants also. So our webinar objective is to share insights on latest innovation in spray drying technology, advancement in design and method for improving efficiency. So this whole program is designed in such a way that all the major aspects of the spray dryer plant and the technology are covered in particular this webinar, which we will have a interactive session with Vijay sir. What kind of the parameters we need to be considered, what are the criticality in the spray drying design and the latest trend and the improvement efficiency point of view, that all points has been covered in this webinar, and you will get to know from the knowledge perspective as well as the practical approach is also provided here in this webinar that we will discuss. And the second objective of this webinar is to create an ecosystem that people can learn and grow about the various kind of equipment, process plant, that may be a spray dryer plant, that may be other plant, because we as a Hitachi Engineering is starting a series of such webinars where all our audience, all our participants, all our customers, all our stakeholder can come and learn about all these process plant and the equipments which we deals into the, and that can be percolated to the all our stakeholders, so that they can also learn and grow about the technicalities about the this kind of systems. So let me introduce our today's experts for the discussion. Mr. Vijay Singh, sir, thank you for joining us, and I welcome you for this webinar, for having you on board for the discussion on specific spray dryer technology, sir.
Thank you. It's my honor.
Yeah. So as far as so all our participant, I would like to let you through the Vijay sir's journey. Vijay sir is having 25 plus years of experience in the process plant industries. Out of his dedicated experience of 16 plus years in the spray dryer plant technology and the operation part specifically for the cellulose kind of application. These applications are very critical to handle, particularly from the when you know from end-to-end solution point of view, from slurry preparation to the final product, which involves lot of process segmentation and the drying part, then the product control. All these parameters comes into the this cellulose kind of application, and Vijay sir is having expertise in that particular field. So we'll get the depth knowledge about his experience, his knowledge, and what kind of criticality, the troubleshooting, all these kind of things we'll get from the Vijay sir in this course of the discussion. Vijay sir is working as General Manager Operations at Ascent Microcell Limited. So Ascent Microcell, I'll just give the short brief about the Ascent Microcell also. Ascent Microcell is the organization who deals into the pharma excipient. It's a 23-year-old organization, and having their office in and manufacturing facility in Dahej and Ahmedabad, two manufacturing units. Now the Ascent Microcell is also listed in National Stock Exchange also. So that is what about the Ascent Microcell. And my name is Shrikant Datir, and I'm working as a sales manager at Shachi Engineering Private Limited. I'm having 12 plus years of experience into the project sales and capital equipment selling. So Shachi Engineering deals into the evaporation and drying technologies, which we call as evaporation and drying technologies. It's having the umbrella of the products, when we say the evaporation and drying technologies, there are the n number of products comes into the that particular vertical. So we do have two business vertical. One is called as a Shachi process, one is called as a Shachi environment. So Shachi process consists of the products like spray dryer, spin flash dryer, integrated fluid bed dryer, flash dryer, cage mill flash dryer. So all or maybe spray coolers. So all these kind of products which directly deals into the product application, and all the process, chemical, pigment, all food, pharma, all the industries. You name the industries, we are having our presence there for such kind of equipments. And another business vertical for Shachi Engineering is that it is the Shachi environment. So Shachi environment, we do the complete end-to-end solution for the industrial wastewater segment. So when I say the end-to-end solution, it involves the complete water cycle of your industrial effluent application. Like that includes your effluent treatment plant, your RO plant, complete ZLD system. So that may be with the all advanced technologies also. That may be conventional system with the steam-based plant, or that may be a MVR-based evaporation plant also. So that all technologies we are having in-house capability for all these kind of project manufacturing, design, manufacturing, supply, and till the handover of the plant. So this is the complete introduction part about our experts, Mr. Vijay Singh, about their organization, and about the Shachi Engineering also. So I hope all the participants are clear about the what is the objective of our webinar, and what are the experts who are the experts who are going to give the knowledge about the on the spray dryer technologies on various aspects. So all of you, I just request you to just give me a thumbs up or maybe reactions in your chat box, so that I can move forward for the further discussion. Okay. So let us deep dive into the further main course of the discussion. Okay. Before moving into the core discussion on the spray dryer technology point of view, let me give you the brief idea about the overview of spray dryer market potential. Okay. So as you see on the screen, the global spray dryer market is experiencing notable growth, and the value of projected growth of the spray dryer market globally is 6.6 billion US dollar by 2028. So you can imagine the growth of spray dryer market in global positioning point of view. And this report is carried out by Research and Markets. You can also get that data from their website. So these are the main market potential of the spray dryer plant, where we can expect the growth in Indian context also. So key factors for driving the growth of spray dryer market is basically the expansion into the food processing part, as well as the pharmaceutical and nutraceutical industries. So these are the main three driving parameter which is driving the market for the spray dryer plants in global aspects. But in India, it is specifically going for the food processing, pharmaceutical, and chemicals. So when I say the chemicals, that includes the lot of variations like agrochemicals, or maybe a specialty chemicals, your fragrances, flavors, or any other segments on that particular segment. So these are the main reason where the spray dryer market is getting potential in India as well as in the global markets. I am giving this overview because this all is related to whatever the discussion we are going to have in next slides, because it is straight away related to that particular segmentation of the markets as well as the industry requirement. Also, what kind of parameter we need to look after and they take care while we are going for the spray dryer operation as well as the procurement. So let us deep down in the main points of our discussion, like latest innovation in the trends of spray dryer technology. So from the advancement point of view, like everyone is aware about the spray dryer, that basically the spray dryer is used for turning liquids into the powder form. But it's not that simple what we express generally. So these are the major points of the discussion which is going on, is getting evolved during the whole process of the spray dryer technology when it gets established. So the major evolve or maybe a major advancement which has been taken in this due course of in this over years of evolution in spray dryer plant is major is about the types of automation system which we use into the spray dryer plant. So Vijay sir, I would like to have your views on this particular point, that what are the major types of automation and how it gets evolved from the considering the present scenario for the spray dryer working.
Yeah, thank you, Shrikant. Basically, we will speak on a product what we are manufacturing is microcrystalline cellulose. So,
Yes, sir.
we have been running Shachi spray dryer here since 2013. So we have two spray dryers from Shachi, and basically both spray dryers are basically the wheel is basically with nozzle type, and there are atomizers which are wheel based also, but there is some difference between the wheel based spray dryer and basically nozzle based spray dryer. So nozzle based spray dryers, you have flexibility to change the nozzle size as per your particle size requirement, whereas wheel based spray dryers are with fixed diameter holes where you don't have this flexibility. And basically spray drying is done to improve the flowability of your powder and basically the better particle size distribution. With
Yes.
nozzle based
Right.
with and with nozzle based atomizer wheels, you have a better consistency and a better control on your particle size distribution. There we make almost 14 different grades of microcrystalline cellulose, where this wheel nozzle based atomizer wheels have a better advantage compared to wheel based spray.
Okay. Yeah.
Secondly, yeah, one more difference I want to put up, the life of the wheel. So the nozzle-based spray dryers normally have a lifespan of 8 to 10 months because the cellulose slurry is abrasive. The cellulose itself is very abrasive.
Very
So
abrasive. Right, sir.
so the hole-based wheels, especially atomizer wheels, you can find a crack at the tip of the wheel, which affects your particle size and the quality. So nozzle-based atomizer wheels are preferred compared to hole-based. Yeah. So over
Okay.
to you, Shrikant.
Yes, thank you. Thank you, sir. Thank you for the insight on the practical point of view as you're operating this spray dryer for MCCP application almost done more than 15 years now. So as for all our participants, please take a note of this because the types of automation in spray dryer technology play a very important role when you go for the selecting of the automation technology. That completely depends upon that what kind of product you are going to deal with, what kind of particle size requirement you want, what kind of the patterns of your product, or maybe the deposition cycle or emission level. All these things are comes into the relatively with the types of automation selection. So thank you, Vijay sir, for this practical approach to this point. The second point of our discussion is about the multi-stage drying technology, which is now getting evolved drastically in Indian market, what we are experiencing as of now, because the product requirement is changing from food and the nutraceutical product point of view. So this multi-stage drying is taking very high demand in the market. So what is your views on this multi-stage drying technology, Vijay sir? If you can just highlight some points on this.
Yeah, Shrikantji, actually now what we have is only basically a single spray drying process we have. Yeah, this multi-stage
Yeah, yeah.
drying basically is for nutraceuticals and other fruit products. These are all special applications. So
Right.
like we can skip this because we have only single stage drying here.
Okay, fine, fine.
Yeah.
So multi-stage drying, just for our participant, let me elaborate it. I'll add some points here for the multi-stage drying technology. So when we say the multi-stage drying technology, so generally it is called as an integrated fluidized bed dryer. So the first stage of drying take place inside the chamber for any product which is suitable for multi-stage drying, and the second stage of drying take place at the integrated fluidized bed dryer, which is integrated at the bottom of conical portion of the our chamber. And the third stage of drying is external vibrating fluidized bed dryer is provided, so that the stages of drying is happens in first stage in chamber, second is integrated fluidized bed dryer, third is in the VFBD. So the complete philosophy for operation is that you need to have a particular particle size requirement, then the kind of product you're operating for this dryer. So specialty applications like nutraceutical or maybe some proteins application, all these kind of application are required the multi-stage drying systems, where this kind of drying system implemented. When such kind of drying implementation is there, so you need to prepare your hot air generation system, because each stage needed a hot air provision, and that too with the variation in the temperature. So that is the complex part of such case of multi-stage drying technology, where you need to provide the variation in the temperature for each stage. So that kind of temperature provision need to be made, and we provide such kind of system, and already establish several plants with such kind of technology for various kind of exotic application. So that is what the milestone we are having as a Shachi Engineering. If you see the we are having one of the food product in India which is getting manufactured in India with the spray dryer technology with multi-stage drying. So Shachi Engineering is only the sole supplier who have supplied the such plant for that kind of product. So that is what we are known for the for multi-stage drying technology. Okay. I'll move to the next part of the discussion. So the third part is about the product quality. So as a spray dryer output is we get generally with the some moisture content or maybe the product quality, the particle size. So all these how we should control, and what are the critical parameter to have the desired product quality. Vijay sir, can you just highlight few points on how we should achieve our required product quality in spray dryer plant?
Yeah. Yeah. See, basically, the challenges with the spray dryer, like when I started handling spray dryers from 2008, those time these parameters were controlled manually, like the outlet temperatures, the feed rate, the inlet temperatures,
Mhm.
all were controlled manually. So the
Right.
dependency on the operator is more, and basically the more the dependency, the more the mistakes, and you have a failure of quality. So with automations, with new innovations, and with better integrations, nowadays basically the spray dryers are automized in a way like the outlet temperature is interlocked with the feed pump. So as far as the outlet temperature goes up and down, your feed rate will be automatically adjusted so that the outlet moisture is not deviated, and you have a uniform consistency in terms of quality is concerned. So these are new developments. Like you can you have to basically do a programming at the design level only. So nowadays
Yes.
automation itself gives you the quality. So it's basically quality by design. You get what you, the concept is QBD, that is quality by design.
Quality by design. Yes, yes. That is what the requirement actually for the market now, because that all parameters need to be taken care at the initial stage itself, and that is what the market is demanding for. Yes, that is what the approach for the quality requirement for the spray drying plant. So I'll move to the fourth point of the discussion, that is the airflow patterns what need to be maintained for the spray dryer plant. Vijay sir, your views on this airflow pattern, sir?
Yeah. This is very critical part as far as the spray dryer is concerned. Like I will give you an example. Like we are facing a lot of issues with the cellulose deposition on the roof of the chamber and the side wall of the chamber. So due to this depositions, since you have continuous heat coming inside your system, the deposited mass will get converted into charred mass, then it will convert into black particles. So you have black particles in your product. So
Yes.
the frequency of these depositions, then you have to stop the spreader, you have to clean it, and then after cleaning again you have to run it. If the airflow pattern is not proper, you will not get a consistent spreader, and the sustainability is hardly for 3 to 4 days only. So now
Mhm.
basically with continuous basically design change with the spreader manufacturers, our problems, our inputs, better basically engineering solutions are now available. So nowadays, like with correct airflow patterns, we say it is an air distributor. There are
Yes.
various basically vane angles are there, co-current, counter current flows are there. So these, it all depends upon product to product. But nowadays, basically with correct airflow patterns, spray dryers are able to sustain for 15 to 20 days with consistent quality. So yes, the airflow pattern is very critical part as far as the spray drying process is concerned.
Yes, of course, sir. That is what we can say, that the if airflow patterns are not there, so you'll not get the desired capacity of the plant. Plant will not run with the consistency. Will not get your product characteristics. So it is straight away directly impact your overall spray dryer performance. What I would like to inform all our participants, when you are going for a spray dryer designing or maybe operation or maybe procurement, so you need to look into the factor of airflow patterns, that how your supplier or maybe how your operations team is handling the airflow patterns. Because airflow pattern, we as a Shachi Engineering itself take this design consideration while doing the basic engineering itself, so we have having our in-house CFD tool, where we establish the complete airflow pattern for application to application. As Vijay sir explained, ki every application is having the particular different airflow patterns, so that airflow patterns need to be identified for each and every application, and that has to be percolated in your actual operation of the plant. We have the airflow pattern established for several applications where we have executed this kind of plant. We can show you the complete simulation for that where the heat zone is coming up, where kind of the flow is taking cyclonic mode. So all these kind of patterns you can identify with the using of this kind of advanced tool. That is what it is, the latest trend in the spray dryer technology, where we use the CFD for the identifying the airflow patterns. Another important part is the air, as Vijay sir mentioned, that air distributor design that play a key role while you're establishing your airflow patterns. So each application requires a different kind of your air distributor design. Again, your automation system also play a very important role while selecting your air distributor. So these are the factors which you should keep in your mind while selecting the particular application, while selecting the particular automation system to establish the airflow patterns also. So thank you, Vijay sir, for adding this practical experience of yours for this airflow patterns. I hope all our participants are getting these points which are related to the the latest innovation and the development in the spray dryer technologies, which we are linking to the practical approach of the spray dryer operations. So that you will get the in-depth knowledge and on-field knowledge, that how this should link to your operations. Vijay sir, we'll move to the next point. The
Yeah,
next point
yeah,
is about the spray dryer plant of new designs for optimizing performance, safety, and product quality in spray dryer plant.
yeah. Yeah, basically, earlier, basically these radars were basically designed only to give you a powder, you can say, of your desired quality and capacity. So during in designs, a lot of safety parameters were not taken care of. But now, if you see during design stage only, like when we do the designing, there are rupture discs which are taken care of while designing, so that if any explosion happens because of under pressure or over pressure, so like the plant people is not affected. It can create a huge accident because MCC is like basically flammable dust can create an explosion. So nowadays,
Right.
with design improvements, we have chambers are incorporated rupture disc with burst indicators. Now there are a lot of tripping set points for the induced draft fan, for the forced draft fan in case of any overpressure or underpressure inside the drying chamber. Now the
Right.
feed pump to the spray dryer is basically linked with atomizer. If atomizer stops, the feed pump will get stopped. Otherwise, what will happen? If atomizer is stopped and feed pump is running, your slurry will come directly to the chamber and to the ducts. So it will be a big cleaning issue, because cooling down the chamber, then a person will enter inside. It's a big exercise. And now atomizer shaft are incorporated with vibration sensors, varying temperatures with temperature indicators. So you have lot of basically process parameters to view, to data to generate, to interpolate the data and take the corrective action accordingly to avoid major failures, breakdown, or any process issues. So, this is what basically few examples of optimization of equipment with product safety and quality sustainability.
Yes, of course, sir. That is the main thing which you need to be taken care while optimizing performance and the product quality. So safety is paramount for each and every plant. So I would like to add a few points to the safety point specifically. Uh, there is a one case actually we are establish and the commission one plant in south region. That is the German giant, and this is for the MCCP application only. So
Kudgi,
as this this
DFE,
yeah, yes, that DFE Pharma.
DFE.
So this is the plant which we have supplied, and we take pride in for supplying this plant, because this is India's biggest plant for MCCP application, sir. It is the plant which is having around 4,800 kg per hour of water evaporation. So this is India's biggest plant. No one has supplied such capacity of plant. No one having expertise for supplying such a huge plant. The chamber diameter itself goes so high, and plant established with all the international norms, because this customer itself is from Germany. So safety parameter they have highlighted very specifically. And as you say, the normal level of safety generally, what a customer is also go, like, they go with the maybe rupture disc or maybe explosion vent for a primarily safety arrangement, that may be for chamber or maybe cyclone. But here are the safety levels are increased by, like first they go with the safety of the explosion vent, then there is a control isolation, then there is a chemical isolation system. So all the safety parameters from the fire point of view as well as explosion point of view, that there has been taken care, and all the systems are imported from USA. So these are the main critical parameter while designing the plant for such critical application like MCCP. So I would like to inform or highlight here to our all participants. So when you are executing project for such application where the criticality is there, you need to identify your application characteristics, that how it should be operated with the optimizing the performance and taking care of the safety. You need to identify the KST and Pmax value of your product, and establish the level of safety which needed in your spray dryer plant. So that is most critical parameter as of now, and that is the latest trend which each and every user and end user is going for the implementation of such technology. All consultant are aware about it now, and they are also requesting us to go for such kind of implementation in the plant. So thank you, Vijay sir, for adding this point here for the safety point of view specifically, because this is much critical point from the operation and the safety point of view for overall plant perspective. Uh, Now, coming to the sixth point here for the spray dryer plant. So as the industry has gone on increasing and the development is going on, all the processes are getting evolved. So now the role of automation is getting evolved also for each and every application. It's not limited to the spray dryer, but it is applicable for all the application and the process plants which are getting evolved. The automation is playing the very important role in the spray dryer. So what is the role of automation in modern spray dryer plant, Vijay sir? What do you feel?
Yeah, see, this automation has definitely revolutionized the way the split drying process is concerned. now as far as the product consistency and the product sustainability is concerned. Nowadays, spray dryers comes with IMCC panel. These are called as intelligent
Yeah.
motor MCC panels. It is basically
Mm-hmm.
smart panels, we say. These panels have a feature that the panels can directly communicate with the field motors and instruments. They can analyze the data, and then they can raise alarm to the operators, to the people, to take action, so that, like, instead of the motors getting burned, instead of things getting shut down or breakdown, you have a step to take action. So IMCC panels definitely is a very beautiful way of automation. And basically now, because of automation, the dependability on the peoples have almost minimized. So which is a very big basically achievement compared to older scenario. Now currently
Right.
we are operating and spray dryer with a capacity of 20 tons a day. Like, this is our production capacity. And
Mm-hmm.
the entire 3 units are integrated. When we say spray dryer, it needs a hot air generator followed by a pneumatic conveying system. See, all these three together things put up will give you a spray dryer. So we have
Mm-hmm.
automized our hot air generator, integrated with spray dryer, integrated pneumatic conveying system with packing system. So this entire operation is managed by two people in a shift. So, like, a huge saving
You
in the, as
saving
far
on
as the,
manpower implementation. Yes, yes, yes.
absolutely, absolutely. So the more the people, more the mistakes. And systems में
Yeah.
system साल में एक बार mistake करेगा. आदमी लोग रोज mistake करते हैं. Like, we have eliminated that mistakes.
Yes, yes, sir. So man error intervention that eliminated completely because of the automation role. Yeah.
Yes.
Yeah. So to the audience, like, the automation, when we say, so there are very critical application, like Vijay sir explained, there are the IMCC, where, you can take care of your field as well as the operation point of view, all inputs to the your system, and the monitoring can be done, and maybe the you can avoid what the maybe, incident which is going to happen, all alarming system you will get from the automation system. That all this can be implemented thoroughly in complete segmentation of your spray dryer plant, from your feed section to your drying section to your product collection section to your hot air generator section to your conveying to your packing section. So everywhere this kind of automation you can implement and you can monitor single-handedly. Now you can imagine the saving in terms of OPEX, when the manpower straight away reduced from, when there is a each shift, if it is the applicable manpower requirement is around 6 man hour, 6 number of manpower, where the straight away come down to 2 number of. So you can imagine the OPEX, the totality of the plant operation. So that is what the impact, where the automation play very important role in the spray dryer technology. Now there is a call always when you go with the technology always comes with a cost, right? So when you go for the high level of automation, so that will cost you also. So that point everyone should keep in your mind. So automation is needed, but what extent, what kind of the level of automation you need, that you need to take care, and that you need to define, so that the plant can be designed accordingly. Because all this consideration we are discussing, this can be always put up in front when the basic engineering of the plant is going on. So that time itself you need to define all those things, and the plant can be designed accordingly, and consideration can be taken into this particular plant. I need to add one example of the automation here. Like earlier days, like when the any choking happens, say for example of cyclone, if any choking happens, so you need to check it manually. You just need to go the manhole whether the complete choking happening or everything, just manual intervention, hammering, and all those things comes into picture. Now the latest way and the latest technology, so, and that is the deciding parameter also on a single note or single loop, you can define whether the operation going is smoothly or maybe not, right? So you just implement the DPT across your cyclone, and this DPT establishment is established with particular value when you commission the plant at design capacity. And you just need to monitor, because that training we generally give all the operators of the plant. You just need to monitor that value. If it is in that particular range, your plant is running fantastically. If it is here and there, or maybe it is differ to your ideal value, there is something wrong. You need to really look into that particular part. So these are the few checkpoints, few tricks which you need to implement when you implement the automation, but how to utilize that automation, that also need to be trained during the training sessions of the spray dryer plant. So that is the role of automation, which play very key importance in the spray dryer operations. Vijay sir will move to the our next point of the discussion. That is the closed loop spray drying system. So this is the new trend and the demand into the market where people are willing to go with the closed loop spray drying system. So what is your thought in it, sir?
Yeah, basically this closed loop spray drying, basically if you have a solvent based spray drying process, definitely you need to recover your solvent back to the process, otherwise it will be it will be not viable, because you cannot lose solvent with such high volume. So
Right, sir.
like after the drying, you have a condenser system where you can condense solvent and you can again take it back to the process. So
Exactly.
now for cellulose spray drying also, like you have uh, there are spray dryers with cyclones, with quadrupoles. Nowadays spray dryers are installed with back filters. So like with back filter as a single point collection, you have almost nil product loss going to the environment. So you are taking care of your product yield, also an environment damage also. So
Yes.
nowadays even water scrubbers are installed after back filters also. So these all are the new developments, basically from cyclone to quadrupole to back filter now. So yes,
Yes.
these are closed loop spray drying system for product recovery.
Yes, of course, of course. You rightly pointed out, sir. The closed loop spray dryer implementation is happens generally where the you feed into the solvent base, right? So that has been the market trend now. But only our finding as a supplier, as a designer of spray dryer plant is that when the closed loop spray dryer, when we say it is generally happens with a very smaller capacity. It's not go on a higher capacity spray dryer because the handling of such slurry in the closed loop with the solvent like ethanol, maybe methanol, so that kind of
Absolutely.
solvent generally is into the feed, and as this is explosive in nature, the criticality in the operation gets increases, and the accordingly you need to maintain your plant with the sync operation with from your automation point of view, your automation point of view, as well as the safety point of view. These three critical parameter play important role while operation of the closed loop spray dryer plant. Only thing is that this closed loop spray dryer system generally gets implemented into the pharmaceutical industry segment where the products are majority evolve into the solvent base only, where we use as a inert gas as a hot air generation like nitrogen. So that was the for the closed loop spray drying system. This solution also we are having, we as a Shachi Engineering having capability to deliver the turnkey project for the closed loop spray drying system also. So I hope all our participants are getting know-how about the critical aspects about the spray drying plant and what are the recent advancement which is getting evolved in the spray dryer technologies. I hope our all participants are getting it. So I will I'll be happy if you someone can give me if he is aware or if he is getting it, thumbs up reaction or something on that particular part, so that we'll move forward for the next slide, which will also give the emphasize on the methods on the reduction on the energy consumption as well as the optimization strategies in spray dryer plant. So I'll move forward accordingly. Okay, thank you. I'll move forward for the next slide. Uh, next topic of the discussion is about the efficiency improvements in spray drying system. So generally spray dryer is the any industry which work on the spray dryer as their main product for main equipment as a product generation. So spray dryer is main equipment for them. But as a backend, like generally people is having a thought that spray dryer is the high energy consuming equipment, but there are the methods and the design parameters where if you implement that, so that can be improve that energy consumption can get improved and there are the methods for it, which we will get understand from Vijay sir, because Vijay sir is continuously giving us the complete practical approach to the advancement point also, as well as from the improvement point of view also. So Vijay sir, what do you think, like what are the methods to reduce energy consumption into the spray drying plant, sir?
Yeah. Now this topic like reduce energy consumption, like uh, whenever you are designing a new system, I think 90% of the schemes, the equipments, the motors, the parameters are selected in a way that they will take care of energy consumption from design point of view only, like right selection of motors from high energy efficient motors, and basically good engineering practices. But when you have an already established setup, so you have very limited scope to improve your energy, reduce your energy consumption. But yes, here also, like last 2 years back, we have installed a feed preheater in the line. Earlier, what was happening, the feed was going to the spreader at room temperature. So the
Right.
delta T is from 25 degree to 300 degrees. Okay, so you need more amount
Mhm.
of heat. So we have installed feed preheaters, which from where the
Okay.
feed goes to spreader with 80 degrees. So now you have a delta T
Mhm.
of 80 to 300. So it directly impacts your coal consumption, fuel consumption, and everything.
Exactly,
So
exactly, sir. Yes.
so you can install feed preheaters there, and rest all are basically very regular things, which I am sure a lot of people will be doing on their regular things also, like leak-proof insulation on hot surfaces. Uh, Once the installation is completed, once the installation is done, nobody do a quality check, preventive check frequently. So insulation have a limited life; it gets damaged, so you have to replace it new insulation. Uh, Hot air generator, there are refractories which needs to be checked every 6 months for breakages, for basically the heat loss from the hot air generator itself is a very big loss, where you can like basically save a lot of energy. And
Yeah.
basically predictive, all are aware of preventive maintenance, I'm sure. So now there
Yes,
is a
yes.
now there is a new terminology called predictive maintenance. So predictive maintenance in the sense ki with your trend, with your preventive maintenance schedule, one even have to predict now, yeah, now this basically equipment is getting old, and in a span of 1 or 1.5 years, the way the vibrations are coming, the way the noise are coming, the MPS are going high, maybe next month it will be we have to replace it with the new. So that is called predictive maintenance. And rest all are very minor things like the bellows and the dampers, and
Yeah.
even we have replaced like lot of belt driven system with direct motor driven, as far as the
Mhm.
FD fans are concerned. So these all are factors are basically to reduce energy consumption. It cannot be quantified or it cannot be measured, but yes, with the monthly bill you can say yes, your energy is saved.
Yeah. Yes, yes, this is very important, sir. Like these are the practical approaches which straight away, when I think a lot of our user already, a lot of our participant already using the spray drying plant. So I feel that is very important input for them also. That what are the checkpoints where they need to look up, where they can reduce their energy consumption. And the point where you mentioned this predictive maintenance, that is very innovative one, because this that is what the evolution is. Now the preventive is coming to the predictive one, right?
Yeah.
Rightly pointed
So
out, sir. Yeah. And then now the second point is the optimization strategies for improving heat transfer, minimizing waste, and scaling up the production. So what do you think, sir, that what kind of strategies we should implement where we can improve our heat transfer, we can improve our minimization of waste, and how we can scale up our production in context of spray drying system?
yeah. So as of now, like whatever we talked on spray drying. So
Right.
now there is a pre-step that is called the wet section for the spray drying,
Yeah.
because
Right.
spray
Right, sir.
drying is only doing the drying part. So now when we say the wet section, that means basically your slurry section. We say it as
Yeah.
a cellulose slurry. So here
Yes.
here basically your wet section should, the process, the peoples, the equipment should be designed in such a way that your wet section percentage of solids in the slurry should be consistent for all batches, for all lots, for
Mhm.
every single hour what is going to the spray dryer, because if the solid content changes from 18% to 16%, 15%, it will directly impact your quality, capacity, and the bulk density parameters. So the wet
Exactly.
section, the process of the wet section should be very robust. So that basically most of the manufacturers only focus on the spray dryer, they don't focus on the wet part. That is the wet section. So we have installed a lot of filters before the slurry goes to spray drying, because during the process,
Mhm.
if any foreign contamination comes into your slurry, like any mechanical washer, nut bolt, gaskets, anything falls into the product, it will directly affect your spray dryer nozzles, atomizer, pump, everything. It will, you can, like people can have practical experience also there. So suitable filters before it goes to spray drying. Even in process,
Yes.
sometimes it happens because of process mistakes, because of people mistake. You don't have homogenized uniform slurry. There are a lot of agglomeration, lot of clumping, lot of
Yes.
drop
Yes.
particles. That will also affect your atomizer nozzles. And basically, the cleaning of spray dryer itself is a very laborious, very time consuming, and very
Yeah.
costly affair as far as the cleaning of spray dryers are concerned. So we have to see if the spray dryer should run consistently for a week, 10 days without any quality failure, without any breakdown failures, to have more viability on your process. So
Yes.
then we have basically whatever comes from the spray dryer, it is sieved, screened, and then sent goes to packing. So the even your precise screen selection, like the sieve should be 60 mesh, 40 mesh, 80 mesh, 100 mesh, all depends upon your product. The sieve selection is also a very important part, because normally we are having wastage of every day like somewhere around 0.5%, less than 0.5% of our total production. Earlier it was
Total
2%.
production.
So with all
Yeah.
these filters, with process improvements, now it is reduced to less than 0.5%. Yeah. Yeah. Uh, Again, next section is the cleaning part. There are CIP systems available with a Wing system, because manual cleaning of big spreader, what you have installed in DFE Kudlur, somewhere around 9.5-meter diameter.
The chamber diameter you're saying?
Yeah,
That
chamber
may be,
diameter 9.5.
yeah, chamber diameter is around 10.5 meters.
10.5. So 10.5-meter
Yeah.
chamber diameter with manual cleaning is almost impossible.
No,
and
no, it is not with the manual cleaning at all. Yeah.
and even
Right.
even 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 if one try to do, you will not get a effective cleaning. So
Yes.
cleaning is
Yes.
one part and effective cleaning is another part. So
Yep.
CIP systems are there, chemical cleaning
Yes.
systems are there now, so which have
Yes.
definitely reduced your downtime. And
Yes.
again, like during scale up, which things I have already mentioned, like the automation should be taken care of. And the most important part is basically from spray dryer to end of packing. The powder
Yeah.
line should be designed in such a way that there is no deposition of powder in the conveying system lines, because
Conveying
it is
system.
continuously exposed to heat. So if anywhere powder get deposited because of bends, long bend, short bend, whatever design issues, so slowly it will get degraded. It will convert into off color, so it will affect your product quality, and that spike even you cannot able to identify in your product also. So this powder conveying line, the design should be taken care of. And yes, safety interlocks, like what I have already discussed with the, if the atomizer get
Yes.
trips, one should stop. If the chamber pressure is
Yes. Yes.
high, ID fan, FD fan should behave accordingly. And one more thing, like basically, what recently we have done 2 years back with your spreader here, we had a sudden power tripping. So in that, what we
Mm-hmm.
have seen, when if the from the torrent side, because a torrent is our power supply here, so suddenly there was a tripping from the torrent side. So that time entire plant got shut, but due to the heat inside the indirect fire hot air generator, this heat was traveling into the chamber because of the
Chamber.
dynamics of the
Mm-hmm.
flow. So whatever the
Mm-hmm.
material which was deposited inside the chamber, it got converted into a huge black ash, and the chamber was
Mm-hmm.
entirely damaged because of this excess heat. So what we have done, we have installed a relief wall in the hot air system, so that if this type of failure happens, immediately the heat will get exposed to atmosphere. The heat will get released to atmosphere,
Atmosphere.
and your chamber is safe. So these all are the
Mm-hmm.
basically practical. When you face that problem, immediately you discuss with
Yeah.
your equipment supplier, and these are the
Yes.
solutions. So in that way, thanks a lot to Shachi also for giving us solutions for our every problems.
Yes. We are always there,
So
sir. always there. Yeah. So, I really, your approach of, explaining the things with context to the practical experiences, sir, that is, we really loved it. And I hope that all our participant is also got the insights of this depth of knowledge from the practical approach point of view. So, and I would like to add one more point here for the optimization strategy point of view. So when the product yield play a very key role when we so for the optimization or all overall what we are talking, it's ultimately comes to the whatever the product you get from your spray dry plant. So that is what the equipment should be designed for. So if it is designed for this capacity, you should get that product capacity output. That is what the main design aspect should be like that. So to give the one example for that, as you mentioned about the DFE, so the product yield for the DFE is like that. The plant is designed for that water evaporation. We are doing that water evaporation. Product capacity is around 1.3 tons per hour. That product capacity we are getting, and even this spray dryer for such a huge spray dryer, it is not even established with the the spray with the back filter arrangement also. That is what the confidence we are having with our design. This system is designed with the cyclone system where you get the product collection below cyclone, and you will not imagine the emission level what we are getting, because the complete monitoring system are established there, and the emission level what we are getting is around 20 ppm. So their PCB norms itself is around 150 ppm, whereas irrespective of that, with comparison to the PCB norm, our design spray dryer plant with the cyclone arrangements, so we are getting 20 ppm of only outlet emissions. So you can imagine the
That's
product yield
fantastic.
and the precision in design of the cyclone. So
Yes.
that is what the
Oh,
practical things what we are getting at the DFE Cuddalore site. So that just because it's about the optimization and the product yield point of view and the strategy point of view, just like to add that point to your points. So that our user also can get or our participant will also get idea about the the what is the importance of the precision in designing of the equipment. That is what we follow at Shachi Engineering. So
cool.
this is as far as the efficiency improvements in the spray drying section. So these are the major points we have discussed. Now come to the Q&A session. I think I would request all our participants to put their question or maybe query in Q&A session or in chat box, so that we can jointly give any replies and the queries for your particular questions to the things are there. So let me check the Q&A session. Q&A section. Maybe I'll inform Vijay sir also. Okay, what are the question we are getting? So there is Mr. Sanjay who has asked the question and the Q&A session for. Hello sir, I want to ask about any digitalization concept applied in your technology. Digitalization approach in our technology. Okay. So Sanjay ji, I would like to add here. So whatever the spray drying plant we have supplied till time, it's completely established with the PLC SCADA system. In one go, you will get all the parameters there at one screen with the completely operating parameters, that what kind of temperature plants is going on, as well as IoT based plant is also there, so that the remotely operation, remotely execution, as well as the remotely troubleshooting can be done from the digitalization point of view. Vijay sir, you would like to add something to this point?
Yeah, it's absolutely what you said. Even I want to be in the same line. The entire now basically when you design any system, and now the plant is coming PLC based, where the real time monitoring is being done. It's captured, and now you have to basically interpolate your data, interpret your data, and then yes, you can have a digitalization concept now. Absolutely.
Here's the question from participant Vijay sir for you. He mentioned the hot air exhaust wall required air to open or air to close, and
So
why?
it's basically a double acting type. Basically, air to open. Basically, whenever you have this type of power failure, immediately the damper will get open, the wall will get open, and the heat in the duct will get be released to atmosphere. It will not go to the system. And whenever the power comes back, again you have to close the valve. So it's air to open and air to close.
Okay. I hope, Mr. Sumit, you got your answer. And the next question is about Mr. Parshuram. He asked about the can we get defined particle size and shape? Mr. Parshuram, I would like to inform you, yes, you can get the defined particle size and shape, but for that you need to define what is your product application, what is the particle size you are looking for, and the shape means like, what kind of shape you need to, globule format, or maybe, any other morphology of the product, what kind of you're looking for. So accordingly, the complete automation system can be selected. Vijay sir, can you
Yeah.
add something to it?
Yeah, Shrikant ji, basically, Parashram ji, with basically with the spreaders, with atomizer type of spreaders, you will get round shaped particles only. Size you can get whatever you want, but the
Yeah,
shape will be spherical round shaped
spherical.
particles. It will not be rod shaped particles, because for rod shaped
Yes,
particles, the terminology is entirely different.
yes, exactly. Hope, Mr. Parshuram, you got your answer. The next, Mr. Vinay asked one question, Vijay sir, to you. Vijay sir mentioned the nozzle type is better, isn't dependent on the viscosity of the feed.
Yeah, basically, yes, viscosity obviously is a very basically important factor when you select your atomizer, this type or what type. Basically, the cellulose slurry, the viscosity is somewhere around 2000 centipoise. But if your viscosity is higher, yes, then this nozzle type can be a challenge for you.
Yes. And viscosity, Mr. Vinay, to your point, viscosity play very important role, not for the automation point of view, but from the feeding point of view, because the pumping system completely changes for
Yeah.
the viscosity, particular kind of viscosity. It depends on the what kind of pumping. That may be a kind of various kind of pumping system comes with the various kind of viscosities. So that is the another aspect which you need to take care when there the feed is having the very high viscosity or maybe very low viscosity. That is also the very important role here. Okay. Then maybe it's depend on rotary atomizer. Mr. Utso mentioned that, but I didn't get what exactly he want to say. Yeah. Yes, Mr. Hemant Kulkarni mentioned about the draft issue. What exactly draft issue means? Like, if you can elaborate more, I can answer you. There are another questions from the user. From Mr. Krishna. He mentioned, sir, airflow patterns to the chamber, how it should be. Sometime the slurry didn't dry and come as wet products. Slurry stick to the wall of chamber. How to overcome this problem? So Mr. Krishnan, this point is what exactly elaborated by the Vijay sir during the discussion. So, because the airflow patterns play a very crucial role to overcome on this particular problem. What kind of application you are dealing with, what kind of automation system you are using, what is the design of your air distributor, accordingly you will get your airflow pattern. Ultimately, the main thing is that what if you are having the existing plan, you need to check whether your existing air distributor is getting sufficient air distribution flow and patterns which needed for that particular application. That need to be analyzed, and afterwards it is not an issue. You can surely overcome on this particular problem, and we will support you on that part. Get us connected with us, and we'll guide you how to overcome on that particular problem. Vijay
And
sir, you
yeah,
would like to add something?
yeah, yeah, Shrikant ji, see, he's writing कि the slurry didn't dry and came as wet slurry. So could be issue with the inlet hot air flow and temperature.
Yeah, yeah, right. The
Maybe that may
temperature
be
also.
your feed is consistent, but maybe your the hot air side, the utility side, your hot air flow and temperature both are crucial here.
Yes, yes. Yes, Mr. Krishna, hope you got your answer. And if you want to overcome on this, we can plan further discussion in detail to overcome on your problem.
Or, or and
There
if
is
your
a
flow and if your flow and temperature is okay, then maybe you are overfeeding your spreader to get more capacity.
yeah. There is a question from Mr. Gautam Kumar B. suggest a suitable Indian vendor for our burner and feed pump application. We are using Felua feed pump and Y-shaft LDO burner in our application, which have been used for more than 25 years. Okay. So what is the application, sir? What application your spray dryer is working for? Because that is completely dependent on that these feed parameters and the feed characteristics, so that the Felua kind of pump, when you say the Felua, in that segment the pumping system can be suggested, and the burner also accordingly. What kind of temperature profile you are maintaining, what kind of the HAG design of yours. So all these parameters are needed to answer particular point of view this question. There are the several reputed vendor for this kind of equipments, which is a substitute to the Felua, substitute to the Y-shaft. So that can be surely considered as a suitable solution for your application. Vijay sir, there is a question from the participant. Is spray drying technology appropriate for material with 75% solid consisting of 90% particle measuring 2 micrometer while aiming to evaporate only 10% of the water content? Okay.
I think
Yeah,
yes,
actually,
Srikanth. Yeah.
so this Mr. Ratna, actually, this is the point of the feasibility point of view. If you can see, if with the 75% of solid content, if your slurry is pumpable, okay, then probably first thing the feasibility need to be tested. So you should conduct the piloting for first for your feed. What kind of application is that need to be elaborated. There is no issue at all to achieving the particle size measuring 2 micrometer, because we have already established the plant with the particle size around 1 micron. Okay, we have already established the plant, which plant is supplied and running from last 1 year at Bangalore location. So there is no issue at all for the particle size point of view. Only thing is that we need to establish the feasibility. If you can explain the this application point of view, there might be we would have given the clear idea whether it is possible or not from the application, because that context we can establish the relevance for the spray drying operation. Mr. Sanjay, there is like, what is the particle size at cyclone inlet and outlet at the spray dryer? What is the efficiency of cyclone? So, Mr. Sanjay, what kind of application you are talking about, that you need to define, and accordingly plant can be designed. What is the particle size requirement you want? And if you are asking about the and the efficiency of cyclone was maybe 99.9% of efficiency what our cyclone generally achieve at the cyclone efficiency, around 10 microns, particle size. So I hope that is what the answer of your question.
Yeah, Shrikantji, basically, what I want to convey to Mr. Sanjay is basically the particle size from the spray dryer outlet will be comparatively coarser if you compare to cyclone. The particle size from the cyclone outlet will be finer than that of spray dryer. If you have different product collections, like if you have a product collection at chamber and if you have product collection at cyclone you can see a finer particle size distribution there.
Yes, exactly, sir. Mr. Gautam Kumar mentioned that, can we install air pre-heating system in existing spray dryer? If yes, how can that be done? Kindly share contact details. Mr. Gautam Kumar, yes, air pre-heating system can be installed in the existing spray dryer system. So a lot of things need to be evaluated first for that in your existing spray dryer system, that what is the mode of air preheating, that maybe you would like to preheating by means of your exhaust air, or maybe a additional steam which is going to your if you are having the steam radiators as a heat source, so that all need to be evaluated. It's not an issue. Existing spray dryer can be implemented with the air preheating system. Surely we will get in touch with you. Our team will connect with you and we can discuss it further with context to installation of the air preheating system. Not an issue. Mr. Parshuram, we have already answered you. Yes, can we get defined particle size and shape? Yes, you can get it. Sir, I want to ask digitalization concept applied in new technology. That is also we have answered to Mr. Sanjay. So I hope we have Krishnan explanation. Mr. Krishnan, sir, kindly give me an explanation of what's happening inside the drying chamber, drying of desired product or evaporation of water or humidification. Okay. So Mr. Krishna, you want to understand what is exactly happening inside the chamber. So as you mentioned, whatever the process you mentioned, one is the evaporation, one is the drying and the humidification. So all complexively, if you collectively see, all things are happening inside the chamber. The mode of thinking is that when you put the slurry in the automation stream, so first it is clear the droplets, that droplets gets dried the means of evaporation. So that means ultimately it's getting dried as well as the evaporation is also getting happens, and the whatever the water vapor which is there of the evaporation, that is carried away with the hot air from outlet of the chamber, right? Vijay sir, would like to add something to it, or
No, I think
like the same?
you have explained very correctly.
Yeah. Yes. So on research. So Mr. Parshuram again asked, like, what is the design basis of chamber diameter with respect to the moisture content and the product outlet? So design basis of chamber diameter with respect to the moisture content and product outlet, it generally depends on the what kind of the evaporation rate working out at the your particular spreader design. Because when you say the product outlet, it means it straight away relate to your feed solid content, right? Whatever the feed solid content, that will come to your product. So ultimately that needs to be evaluated what kind of evaporation rate is coming, and accordingly the size of your chamber gets worked out. So there are the in-house development plan for it, that what kind of things are need to be put up into the system, and accordingly size gets worked out. So I hope Mr. Parshuram, that is the question of yours. So Mr. Sanjay asked, what is the MOC of the spray dryer and how to resolve solid settling issue at the bottom of application? What is the MOC of spray dryer and how to resolve the solid settling? What is the MOC can be anything, Mr. Sanjay, just based on your application and the compatibility. MOC can be 304, MOC can be 316, MOC can be again higher grade MOCs also. MOC not an issue for spray dryer at all, but need to be checked with the compatibility and the surface finishing, what you need for your product, that you need to evolve, that you need to also define, or based on the application we can also suggest you, and resolve the solid settling issue at the bottom for the application. Solid, you mean to say the bottom deposition, what is happening inside the chamber? If that is the case, I think Vijay sir already answered that question during the discussion, as well as one of the question here during the chat also, for the settling, that you need to check whether what kind of temperature profile you are maintaining. Temperature should not be in the particular what requirement, what is your flow pattern, your air distributor design. So all things need to be taken care for that.
And especially your basically the powder conveying system,
Powder conveying system, right?
Designed. It should technically, it should be straight. There should be no bend. If bends are there, it should be long bend, not short bend. And the amount of bends, it all depends upon that.
Yes. So I think completely all questions has been answered now, and just I would like to inform all our participants that we have mentioned that there will be the bonus point for our all the participants. Just a moment, let me share screen so that all our participants will get idea what the bonus point I am talking about for all our participants. So as you are able to see my screen, so when I say the bonus point, so it's a bonus point means it's a all our participant will get a free ebook for joining this webinar for this particular spray dryer points and the discussion what we discuss. So a lot of content will be there from the technical point of view, which you will get in a due course of time. Also all the our participants who join this webinar, they will get a free pass for more webinar series. As I explained earlier during the start of webinar, now the Shachi Engineering starting the series of webinar on all our products like spray dryers, spray coolers, spin flash dryers, zero liquid discharge plant, the complete MVR based evaporation plant, steam based evaporation plant, ATFDs. So all our equipments are getting covered in this webinar series, and the industry experts, like for this particular segment, like Vijay sir was there to guide us and share his knowledge and his experience. Like there are a number of chief speaker and guest will be there, and the webinar panel will be there to interact with all of you. So you'll get the free post for such webinars, and all the participants who will complete consecutively 3 webinars of Shachi Engineering, they will get a certificate for completing the webinar also. That is also the bonus point which we have highlighted here. And that is the learning for you and for us also, because we as a Shachi Engineering, we feel that sharing is gaining. When you go on sharing your knowledge, you also gain out of it. The whatever the knowledge, because knowledge when it's shared, it gets evolved and it gets spread, and that will be useful for everyone. So I think we have covered all the topics of our webinar, and I would like to special thanks to Vijay sir for sharing his knowledge, his experience throughout this webinar with context to their practical approaches and the key parameters what he shared during the discussion. Thank you, Vijay sir. Thank you so much for
Thank you,
joining us.
Shrikant. Thank you. Thank you.
Yes,
Thank you for giving me an
and
opportunity to. Yeah.
yes. It's our pleasure, sir, that you are there for the discussion, and it's the thing for our participant also, that such a experienced speaker will there who share all his knowledge all about the spray drying technology, and that to respect to the critical application like MCCP. So I hope all our participant is also got what they joined for, and whatever the knowledge is there, I feel they will implement in their processes, in their spray dryer plant, or whenever they go for the procurement or design engineering, or maybe in their operations, because we are discussed a lot of things about the practical approaches and operation things about the spray dryer plant. So thank you all for joining us, and we will be connecting again for all such kind of webinar for all other spray dryer or other spray cooler, spin flash dryer, ZLD kind of webinars will be there, and you will be get notified by our marketing team. And stay tuned with the Shachi Engineering, and we'll be connect again. Thank you. Thank you so much. Thank you once again.
Thank you, Shachi. Thank you, all participants.
Yeah.
Thank you, Shrikant.
Yeah.
Bye bye.
Yeah.
Have a
Thank
good
you,
day.
Vijay sir. Thank you.
Bye.
Thank you. Thank you. Yes. Bye.